But we love to get that real world data. It gives us the ability to be even less conservative with our system size. I mean, we're well known among our peers for sizing our equipment extremely tight to the loads. Basically, that is to say, by the book, doing everything the manual J says. But more and more contractors are actually looking at the data post-install, and they're learning from it. You look at the data and you're like, oh, wow, I thought the heating load was going to be 30,000 BTUs per hour, but it looks like it's more like 20. And then you do that over and over again, and it keeps happening. Okay, I can keep my heating output really tight to the manual J, and we're going to be okay on those really cold days.
That tip is awesome. Get some of that data just to get that continuous improvement and learning.
Hello and welcome to the Heat Pump Podcast. I'm Ed Smith.
And I'm Eric Fitz. We are co-founders of Amply Energy.
Today we have John Semmelhack here with us from Charlottesville, Virginia, where it is design day temperatures right now, which will be fun to dig into that a bit more. Rather than me introduce you, would love for you to just introduce yourself and tell folks a bit about who you are and how you got to where you are.
Oh, sure. Thanks, guys. Fun to be on the pod. I'm a big fan. Been listening since just about the beginning, since episode 2 or 3, maybe. It's great to be on. Thanks. Yeah, so the Comfort Squad, we're a home performance contractor with a focus on HVAC solutions based in Central Virginia. We work in Richmond, state capital, as well as Charlottesville, where I'm based. My business partner is Neil Comparetto, who runs our installation side, and I kind of run the admin, design, and sales side for the most part, with a small bit of crossover in between. We're a 9-person team, 3 installation trucks, and a service maintenance vehicle. We've been doing this since 2019, doing the contracting work. I've been doing home performance consulting since 2007, 2008. I got my started as a home energy rater, which I think is maybe similar to some of your other guests or recent guests, upcoming guests. So that's interesting. So yeah, I got started researching my own house. My wife and I bought a vacant lot in Charlottesville in 2005, and we were figuring out how to build it, who we were going to work with. I'm a former bicycle racer and still ride bikes a lot. I find that bike racers, especially, or anybody who does any kind of pack riding out on the road, really gets energy efficiency, drafting, conserving. So just, I don't know. I feel like people who ride bikes get what we do in the home performance world. Anyway.
I didn't realize that. Did you race in college or?
Yes. Yeah. I raced in high school and college and a little bit after college. Yeah.
So Eric did some racing, and then it was over 20 years ago. Eric and I rode with 3 other buddies, rode our bikes cross country.
Nice. I've never done an adventure like that, but yeah, that's awesome.
It was great. And we talked a lot about efficiency.
See what I mean?
We were in a straight line. Yeah.
So I went to school at University of Colorado. I went to college in Boulder, University of Colorado. Their houses there with like solar thermal panels, even some solar PV, rooftop PV. There was a wind turbine research facility just south of town at the time. And so it was just kind of in the air out there. So it was stuff that I was interested in, but didn't know a lot about. But then when we moved to Charlottesville and I started doing research on like how to build an energy efficient house, what are the options, how far do you go with insulation and window performance and cost trade-offs and all that kind of stuff. I found out about the world of home energy ratings and home energy raters, and all at the same time found out about passive house, super airtight and super insulated buildings. And I was like, oh, wow, this is awesome. This is really cool. I love houses. I like thinking about houses. This is all just numbers. I'm good at like doing basic algebra. I'm not great at like higher level math, but doing the basic heat flow calculations, that's pretty straightforward stuff. And figuring out all the optimizations, that was great. And so I decided to get trained as a home energy rater, which I did in 2007, and started my consulting business, which was Think Little Home Energy, in 2008. Early on in my consulting career, I really realized that among all the problems with buildings in the world and in our country, Mechanical systems seem to be the hardest things to fix, both from a design and an installation standpoint. So I just really dug in. There was a just fantastic, at the time, LinkedIn used to have great forums back in the day. They don't have that service anymore, but there was a building science forum that was maintained by David Butler, who was just a fantastic, I believe he was an electrical engineer originally, but then kind of switched over to mechanical system design. He's written several articles on the Energy Vanguard blog, and he's still, I think he's retired now in somewhere in the middle of nowhere in Arizona. But anyway, his forum and talking with other folks at conferences like Mark Rosenbaum and Gary Nelson and just so many great people that I've talked to over the years, and research reports from NREL and Building Science Corp and et cetera, et cetera, et cetera. You can really learn a lot from your computer screen. I started offering HVAC design consulting services to some of my clients, especially the passive house clients who really needed someone who understand how truly low the heating and cooling loads are in passive houses, and figuring out appropriate designs and equipment to serve those houses. So I started doing that in like 2010, roughly, and relatively quickly realized that it was still a challenge to get my designs installed the way I wanted them installed. So just getting the ductwork installed in the right layout, the right size, as tight as I wanted it, the correct registers, the correct filters, all of that stuff. We would do the airflow balancing and some of the commissioning work on the tail end of things, so at least had control over that. But I kind of early on thought, sure, yeah.
Well, I wanted to ask a question on that. I didn't mean to interrupt you, but did you find it was because the installers didn't believe your designs and like it won't work this way based on experience, didn't understand it, or what led to like your design not necessarily getting implemented the way you wanted it?
Some of it was just like, oh, you care about the registers? Like,
got it.
Like this, well, we put in what we normally install. Like we didn't even look at your register schedule.
Yeah.
Stuff like that. But other times in a lot of houses we do in new construction, we often will do like a central return grill, a central return filter grill. And because we've calculated what the expected like bedroom pressurization is going to be, and it's going to be plenty low enough to do what we need to do without having to have a dedicated return in a bedroom. And some of the installers were like good installers and are worried about the airflow and worried about the return airflow and the overpressurization of those rooms, but didn't have the practical measured experience doing these kinds of systems and didn't really understand that we were talking about much smaller systems with much lower airflows. Therefore, the room pressurization becomes less and less, and that's less of an issue the less airflow you deliver to it. So it was various things, but yeah, just, the headaches that were involved in getting stuff installed right and working right. And I just thought, man, this would be so much better if we just did the contracting work ourselves, but I didn't have that skill set and kind of needed to meet the right person who was interested in that. And I finally met that right person in 2017 on Facebook.
Amazing.
Oh, wow.
Through the HVAC school Facebook group that Brian Orr started many years ago and is still going strong and has tens of thousands of users. So Comparetto had recently moved to the Richmond, Virginia area from Maryland. And I caught a post that he did posting about some Fujitsu ducted heat pumps that I thought we were the only ones in the world who were speccing and installing. And he had recently installed ones in Maryland and had a little video about it. And I was like, oh, okay, cool. And so I just checked out some of his other posts, saw that he was one of the moderators for the group. And I was like, okay, that gives you some escalation of my esteem. And so I just reached out to him and said, hey, I saw you moved to Richmond. I'm in Charlottesville. We should meet up. And he already knew my name and from some articles and podcasts that I had done in the past. And so we met up. I said, just pitched it straight away, like, hey, we should start a HVAC contracting business. We're doing great design work, but we'd be so much better if we were installing it. What do you think? And he was like, sounds great, but I just moved. I just took this new job. Let me get back to you. So he worked the job that he was at for a while, wasn't super happy with it. And so about a year later, he was like, okay, let's do this.
Cool.
So that was like that was 2018. So we started January of 2019. wound up merging the companies together and rebranding as the Comfort Squad in 22, but we've been doing the contracting side since 2019. Like historically, we've done a lot of new construction, custom homes, high performance multifamily jobs, and we're really trying to push more and more into existing homes for various reasons, but a lot of it is it's from a scheduling standpoint. New construction, doing all new construction is tough. We really need to be a lot more existing home improvements and change outs, because those are just, especially the way we do them, they're 95% of them are planned out well in advance with a flexible schedule, and new construction is not that.
Right.
New construction is delay. Why didn't you start last week?
Right. So today, roughly, what percentage are retrofit projects? Like 10%? You at 20%?
No. Existing homes is like a third of our business. Yeah. Yeah, and we're trying to get that. We're trying to flip that to be like 2/3 existing, 1/3 new build. But it's tough because like my initial 10 plus years of consulting work was almost entirely in new construction. So all of my contacts, my network is all new construction. And we brought many of those clients in, and many of our referrals are coming from that kind of pool. So it's slowly building up in terms of the existing home portfolio.
I was thinking, you prompted a couple different things in my just hearing your amazing story. What are, beyond the basic differences between new construction and retrofit, you just mentioned of like how you're sourcing the projects and the scheduling challenges or not lack of challenges, other reasons why you're particularly interested in moving into retrofits versus new construction? Is there,
especially me, I'm a big proponent of electrify everything, which doesn't technically mean everything, but everything that we can, everything that's reasonable. It's not something that you just flip a switch on, but for an individual house, you can flip a switch on it, essentially. And so this is going to take many, many years to convert all of these buildings. So we focus on houses. I think we have a path to near zero pollution from our energy production with clean electricity. And we can convert our buildings to run entirely on electricity and without breaking the grid. It's going to take some work in terms of efficiency on the building end. It's going to take lots of work on the grid end of things. We work in the buildings. The rest of the stuff, I listen to a million podcasts about the other stuff, but that's in the category of not my job. And I don't worry about it too much. I mean, I'm interested, like, okay, earlier in the week when we had, some really cold weather, I was looking at, we're in the PJM and energy market, and I was looking at what PJM was doing and what my local Dominion Energy grid was doing. Were we going to hit an all-time peak because we were projected to, but we didn't because it wasn't quite as cold as it was. So I'm interested in that stuff. But in terms of how we talk with clients about that stuff, the grid has nothing to do with it unless the grid is paying us or paying our clients to do something different that benefits them. And right now where we are, we don't have that kind of thing. We have fairly low flat rates. We have an optional time of use rate where there's not a lot of spread. There's no incentive where we are to do anything different. So, and we can get into that in terms of like electric resistance heating and with heat pump systems versus, full cold climate heat pumps with no backup or no supplemental heat versus hybrid systems and so on. But where we are, we generally size the heat pumps to the cooling load, and we get what we get with the heating. Typically, we're still on paper and through monitored results, we're typically still getting like 98 or 99% of a typical year's BTUs from the heat pump system, with a very small percentage from electric resistance.
Fantastic.
And part of that is because we are using some cold climate heat pumps and some kind of medium heat, like the Daikin Fitz system. It's not, or at least the current generation, it has decent heating performance. It's not as bad as a standard single stage heat pump. It's not as good as a true cold climate heat pump. So it's in between, which works great for many buildings in our climate zone. So yeah, we have a lot of systems where there's not much use of electric resistance heat.
Nice. And we certainly spent a lot of time thinking about some of the challenges of electrification, and we're generally fairly optimistic from basic things like if you have an existing home where you're using electric resistance water heating, so that can easily be a 5,000 watt, 6,000 watt, 2 elements in that unit. If you swap that out for a heat pump water heater, which running just in the heat pump mode will pull like 300 watts, you suddenly free up a bunch of capacity both on the homeowner's panel, but also on the grid for then If you're going to put in a new heat pump for space heating, you have now freed up 5 kW heat strips if you need them, or anything else you might electrify in the house. So it's...
Yeah, and certainly at the building level, those things we're definitely looking at and thinking about the long-range planning for a customer. Where we are and the clients that we've worked with, we've been fortunate that most of our clients already have 200 amp electrical service. So the electrical service is already fine for full electrification with EV charging. Sometimes they might need some rearrangement of circuits if they don't have enough slots in the panel, or they might need to add on a sub panel to add on additional circuit breakers. But the actual service that's coming in is usually fine. So we haven't had too many situations yet where we've had to deal with like really fine-tuning the specs. But it's a fun game to play. I play that in my own house, even though we have 200 amp service. We're a 4-person household with an attached apartment with my mother-in-law in it. So we have 5 people and all electric. So 2 heat pumps, 2 clothes dryers, a dishwasher, 2 ovens, 2 cooktops, et cetera, et cetera, et cetera. We don't use more than 50 amps ever over a 15-minute period, measured. So I could add on 2 more units in my backyard on my existing 200 amp service.
That's awesome. John, this has been an awesome overview of how you got here in Comfort Squad. And I want to talk about sort of a typical job at Comfort Squad, but I want to put this in the context of when you and I were chatting last. One of the things you told me was you've listened to the pod a bunch, which we appreciate, but sometimes you got some disagreements, you got some quibbles with when we talk about ductless versus ducted. So tell us about the housing stock, tell us about a typical solution, and tell us about your views on ducted versus ductless and why you do what you do for the building stock around you.
And this is it's probably regional and definitely is case by case for each individual house. Where we are, most houses already have a ducted system as their primary heating and cooling. Some houses have multiple ducted systems. So if the ductwork is in okay shape, if it's in conditioned space or is going to be brought into conditioned space as part of our work or some adjacent work, if there's no big comfort issues, a ducted heat pump is totally the way to go. Let's reuse we have good comfort. If we have good comfort already, we're not getting a bunch of energy losses from the ductwork. The customer is used to this system, is used to the registers that they have, isn't complaining about them. If that's all the case, then why would we put a thing on the wall that lots of people don't really like? I mean, yes, they do disappear eventually from your vision mostly, but when somebody's considering adding that to their house, for a lot of people, it's like, oh no, I would never do that unless it was like the, super low cost solution, which it often is for standalone smaller additions or small studio apartment additions or things like that. But it's never our go-to solution, ductless.
Makes sense.
And we're really big on super filtration for our system. So MERV 13 is our starting point. We do easy add-ons to go to MERV 16. We have our first client where we're going to do central HEPA filtration, not a bypass HEPA. It's going to be central HEPA, just straight through. That'll take some extra planning, and then there's definitely some added cost, but it's totally doable depending on the airflow that you're trying to move and the space constraints that you have. In this case, it's a passive house, so the airflow is pretty small, and we have plenty of space to do it. But yeah, I mean, ductless, I've seen in our mother-in-law apartment, it needs to be cleaned right now. In fact, it's nasty inside, especially if you ever use it for cooling. You wind up with that moisture on the coil, and it's all plastic parts inside except for the coil. It all just attracts all the dust, all the organic matter, and then you've got a cool, moist environment with a bunch of organic matter trapped inside, and that's a recipe for mold and other microbial growth. That's bad.
You really made that sound appealing. Yeah, I agree.
Anyway, ductless systems, they have their place. There's some good benefits to them, but they do need more maintenance, more regular maintenance than a ducted system does. We have multiple 6-year, at the 6-year mark, maintenance visits. In my case, in my own house, I'm almost at the 10-year mark on my ducted system, and I can take a picture of a shiny, clean return duct and the inside of the kind of the inlet, return inlet side of the air handler, and it's like nearly factory new. And so we have, because we're doing great filtration, either at a filter grill or at a cabinet filter just before the air handler, depending on what the existing ductwork is that we're working with. And so that filter keeps everything downstream clean, and it makes it so that we have to do minimal cleaning of air handlers and coils and fan motors, and it also keeps the air clean for the occupants, which is something that the ductless systems cannot do at this point. Or sorry, not that they can't, they don't. And they don't because they would be much larger if they had appropriate filter for doing the same kind of thing that we do. Or if they kept the size the same, they would have a lot higher fan power to push the air through a small, high-efficient filter, and they'd be a lot noisier inside, both of which the ductless manufacturers are not interested in for the most part. I think there's maybe one product that's out there that has a optional MERV 11 or MERV 13 filter from Panasonic, maybe, and it's a significantly larger indoor unit to accommodate that filter.
Totally. Yeah, we're with you. Like, if you got good ductwork, I mean, you're going to do a ducted system all day long. If you are in the Northeast, where lots of homes, all they have is a boiler, they're on hydronic heating, they have no ductwork at all, you're going to go for ductless. And there's trade-offs with both of them, but that makes perfect sense.
Right. Yeah. Or you can, depending on the house and kind of, is it an unfinished basement or a finished basement, or we have a ton of crawl spaces here. If you have unfinished spaces, it's usually straightforward to retrofit that ductwork in. So, but yeah, it depends on what you're working with to start with. I know you all had a lot of initial guests in the Northeast, so you have a particular housing stock that's up there. And I get the ductless solution can be really useful. I don't think it should be the only tool in your tool belt, because then either you are limiting your number of clients or you're pitching something that isn't the best fit for the house.
Yeah, there's definitely a risk.
Totally
we see this a lot, particularly in the early days of the cold climate heat pump wave in the Northeast, where you've got these small homes that were built 100 years ago, lots of small bedrooms, and the smallest ductless head size that was available was like a 6,000 BTU nominal unit. And, well, if this is the only option I have, I'm going to put it in every room. But turns out you put it in a tiny room, you're going to have potentially way oversized for that space, and you get a lot of short cycling, a lot of problems. Unless you switch to like a small, low static pressure. It's a great thing to do, and it's like a second story of a home where you might have ductless on the first story, but then you do a small ducted unit on the second story, and you can actually get to matching the loads and have a comfortable system for the homeowner.
Right.
So it's
yeah. And as far as cold climate heat pumps go, ductless cold climate heat pumps have definitely been leading the way, and ducted versions of those have been lagging behind, coming in behind. But we're now at a point where we're getting more and more and more options for ducted systems, where almost every brand has something available with their own. Every piece of equipment has its own, and brand has its own pros and cons. But yeah, I think we have a lot of options now in the ducted world for those really high heat output situations.
So you were painting before sort of Comfort Squad and what you guys do. And I'm curious, I want to ask about a typical job. You might just then say, like, there is no typical job. But it was a great answer. But I'm wondering, like, if for the third of your business that's retrofits and the 2/3 that's new construction, on average, do those end up looking different? Like, what does an average solution look like in each of those categories? Are they different?
The equipment is often the same or very similar. I mean, with existing homes, we're usually working with the ductwork that we're given. We're usually not doing major, I shouldn't say that. It depends on the house. We've had a lot of really bad clients coming to us because they have a mold problem in their home. They have inspected and tested mold. Somebody else has inspected and tested mold in their ductwork, and they have decided that they want to replace it, and they get referred to us. And so then that's more like new construction, except you're working with a household that's probably living there, which has its own challenges. But in terms of like a more typical kind of just equipment replacement or electrification job, where we are working with the existing ductwork and we're probably not changing duct sizes other than adjacent to the air handler. We're not changing registers. We're not changing return grills. Then, yeah, we're working with, we may be working with the existing constraints from the existing electrical, perhaps constraints from the existing refrigerant pipe sizes, perhaps. So we're always looking at what do we have, what equipment is going to work with what we have. Is that the right equipment for the job, or do we need to change out the pipes? We're always in an existing house. We are 100% adding a MERV 13 or higher nominal 5-inch deep media filter cabinet so that we're getting really great filtration while typically reducing the pressure drop from the filter, because most of our even clients who have a MERV 2 or MERV 4 filter, it's usually undersized, and we're usually actually improving the pressure drop of the filter, lowering the pressure drop, while taking the house to a very good level of filtration performance. So it's a nice thing to have. We're usually reducing the overall nominal capacity of the equipment quite a bit. When we're talking about furnaces, we're often going from a nominal 72 or 80,000 BTU per hour output furnace, and those are usually oversized by 3, 4, maybe even 5 times compared to the load. And you can see that the data, if we have a data feed, many of our projects, we have the time to either install an energy monitor in the home so that we can see the runtime, the air handler and or the whatever outdoor unit they have, or furnace. Or we have an existing Ecobee thermostat where we have easy ability to get the historical data feed in 5-minute increments so we can see what's going on, and we can actually look at a design temperature day and see that furnace runs for 8 minutes and then shuts off for 15, and then things like that, and actually calculate how oversized it is. On the cooling side, it's existing cooling systems. It definitely varies. Sometimes we actually find that the installed cooling system we think is the appropriate size. We haven't yet found one that was undersized. But it's fairly common for us to come down by a half ton or a ton. Rarely is it more than a ton, but every now and then we might come down a ton and a half if it's really oversized. But it's the furnaces, it's the heat output that is way off the charts compared to what is actually needed. So yeah, we're usually reducing that stuff, and so we're reducing the airflow of the systems compared to what they have or what they ought to have, depending on what their duct pressure is. And so by doing that, we're often taking like mediocre efficiency or like relatively high static pressure duct systems and bringing them into a good range without doing anything to the ductwork, or other than our plenum connections and the filter. So making that, you reduce the airflow by 25%, then you're making like a 40+% change in static pressure.
Man, I love hearing this. It's just win-win-win. You're getting better filtration, lower static pressure, you're right-sizing the equipment, so then the equipment's actually operating more, which leads to more comfort for the homeowner.
Yes.
You're getting more filtration because the air is actually moving in the building instead of cycling on and off all the time, especially in the winter if you're oversized by 2, 3, 4x. That's awesome.
Yeah, it starts off with a heating cooling load calculation, or in my opinion, even better is real world runtime that's measured through a thermostat or an energy monitor, combined with in-field performance measurements of what the actual heat output is for that system or the cooling output is for that system. So you can really put those things together and calculate what the real house load is, what the real heat gain is on that design day, or the real heat loss is on that winter design day.
I love that. Would you put that in the context of your sales process? Like, I'm dying to know, for the moment a customer comes to you or you get the customer, like, I'd love to hear about the interactions with the customer and then the analytics you're doing and how you sort of communicate that to then get to the point where you've got the design that they're bought into, because that's where folks have questions and trouble. Like, the homeowner's not interested in data and they won't believe me, and it just sounds bad to reduce the furnace by half. They're worried they're going to be cold. This is the sort of thing that happens. So I'd love to learn about your sales process and how it's woven into design.
We're still small and we're still young. I feel like we tend to get clients who are already aligned with where we want to go. We tend to get clients who are already more analytic minded. We have a lot of engineer clients, which is, I know some HVAC contractors hate engineer clients, like they have a bad reputation in the HVAC contracting world, but we love
Eric is a terrible HVAC customer. Yeah. He is the worst.
Yeah, anyway, our engineer clients are fantastic because they understand that we have a particular expertise. They may understand enough about what we're doing to really get it. And they ask a lot of really good questions. And so I think it works out well. We love engineer clients, so we could take all the engineers, everybody else too. But I guess our kind of typical existing home process is we're typically going into a home to do a home performance consult that is paid by the homeowner. So it's not a complimentary consult.
It's not a free quote.
It's not a free quote, but we're trying out some interesting things around that we can maybe talk about. But we're trying to get, basically, big picture, we're trying to gather enough data to do good heating, cooling load calculations and understand the space limitations for a new air handler, the refrigerant pipe sizes, the electrical stuff, so that we can rule out a bunch of equipment and narrow in on what we think is going to be the right piece of equipment for if we have, depending on the time frame and the number of unknowns in the house. For instance, you might have a huge house and you don't really know what the wall insulation is. It's nice to have, if you've got the time, we'll propose like, hey, would you like us to add on an energy monitor or do a temporary Ecobee thermostat for a small extra fee? And here's what that gives us. It gives us very precise information, not perfect, but very precise information about the runtime of your existing system. And we can measure the performance while we're there for the consult of your existing stuff and then put those things together in a spreadsheet and to really say, okay, this is your total heat loss, and the winter design day is 18 in Charlottesville, it's 21 in Richmond. So when we're in the ballpark of 20 degrees, here's what your heat loss is. And then we can do the same thing for cooling. Or sometimes we might be able to only do it for one season and not the other, because we don't often have like 8 months of lead time before these jobs. We have like maybe 3, maybe 4. So it depends on the situation. But we love to get that real world data, and it gives us the ability to be even less conservative with our system size. I mean, we're well known among our peers for sizing our equipment extremely tight to the loads. Basically, and that is to say, by the book.
Yeah.
Doing everything the manual J says, taking all of adjusting the loads properly for all of the shading that you have for the real world performance of all the different components of the enclosure. And then sizing the system tight to the loads, and it works. We have a bunch of monitor data. And that's one of the things that I think it is growing in the HVAC contracting world, is more and more contractors, oh, wow, it's easy-ish now, not super, it could be easier. The manufacturers could roll all of this stuff into their equipment and give us easy real-world performance feedback. But more and more contractors are actually looking at the data post-install, and they're learning from it. And so you do that, you do an install, and you look at the data, and you're like, oh, wow, I thought the heating load was going to be 30,000 BTUs per hour, but it looks like it's more like 20. Why is my manual J so higher? Why is my manual J heat loss so higher than what real world is? And then you do that over and over again, and it keeps happening. Okay, I can keep my heating output really tight to the manual J, and we're going to be okay on those really cold days.
That tip is awesome. There are a lot of folks that think that, I get very few callbacks. That means I've got things dialed in, things are going great. And that may be the case. But holy cow, if you can, just for a few clients that you have, get some of that data just to get that continuous improvement and learning, you'll discover that you can adjust how you're selecting equipment and be smarter, dial in more, and it's going to result in better outcomes for both you as a business and for your customers. And so it's a jump to, if you've got an existing sales process and you're like, I'm now going to propose to the homeowner, I'm going to come in, I'm going to install this Ecobee thermostat. We're going to look at the data. There aren't a lot of folks doing that, but man, it's worth a try.
We've really found that this kind of process really sets us apart. Like being upfront with the homeowner that you want to slow it down. You want to really understand their house and propose a solution that's really custom tailored to their house and that you know what you're doing. Yeah, that really, we've gotten that feedback over and over again from existing home clients that they really appreciate that. I mean, it's one thing if it's an emergency situation, then this process doesn't work for emergency changeouts. We know that. But for the planned equipment changeout, this is the process. Like, this is what should be done. Like, nobody goes to buy a new car without understanding their driving needs.
That's right.
Yeah.
And also nobody if you have the resources, nobody goes to buy a new car on an emergency basis either.
That's right.
And nobody should be replacing their heating and cooling equipment on an emergency basis. They should do it in advance after a nice long life, but not a complete failure of their system. Because if they wait until failure, they don't have the opportunity to get the right new equipment in. And they might wind up paying for speed while at the same time sacrificing performance.
You're hitting on a bunch of topics that have come up on the pod lately with maybe the best articulation of the solution that I've heard yet. We've heard a bunch of folks comment on an industry. Folks are hesitant to size to the manual J. You always want to build in these safety factors, even though manual J already has a decent safety factor into it.
Yes.
And it's getting more competitive, right? There's a lot of people hanging up shingles, installing heat pumps. And so people feel the need to quote on speed and quote on price. And so as things go in that direction, it is extremely counterintuitive to say, actually, slow it down and go smaller and go tighter. But what I'm hearing you say is like, that screams to me differentiation.
Yeah,
like I bet
absolutely.
you are often in a race of one with just the comfort squad competing.
Yeah, often. I mean, not always. I mean, we may quickly get to a race of one, but maybe initially we're not. But hopefully after they talk to us, and certainly if they bring us in for that consult, we're usually the ones getting the work.
That's awesome.
Yeah, one of the things that we're trying out is because we have enough information about existing homes and what we typically install, we have a pretty good idea of what the equipment size is going to be. The more models you do, the less you need to do a model. The more energy models you do, the more manual days you do, the less. I mean, it's not always perfect, but you probably have a good sense of what the solution is going to be. And I mean, one thing that we've tried recently with a client was a 10-minute video walkthrough, FaceTime walkthrough with the client so that I can look up their house from the address. So I can see kind of the size and roughly the shape and the amount of window area and things like that. Is it typical or is it something that's a little bit outside the norm? And then with a 10-minute walkthrough, I can see their mechanical room. I can get model numbers on their existing equipment. I can see where their outdoor unit is. I can get the model number on their air conditioning system. They can tell me about where their ductwork is. And I can get them a preliminary proposal. It's not a firm proposal. So the way that we're trying to do this, and we're going to keep trying this, I think it is good promises. We're going to get them a preliminary proposal and say, okay, the next step is you pay us $500 to come to a console. If you move forward with the install, that's deducted from the final price. But we come in and do the console. We do our blower door test. We do our heat load calculations. Then we fine tune the equipment selection. We uncover anything that there's going to be some things that we missed during that 10-minute video call. Usually, we're going to make that proposal equipment size maybe a little bit on the higher end of things and bring it down, hopefully, instead of going the other way around. Customers like to see that because they might be able to get a little bit of price reduction there. And then we firm up the proposal and send it back to them. And so far, that has been a good process because it enables us to respond quickly to the customer, even if we don't do emergency work for the most part, but customers they call you, they want to hear back from you. They would like to not have to wait 3 months to get a proposal when your competitors are giving them a proposal within a matter of a day. So that kind of thing allows us to turn around a preliminary proposal to show them that we are in the same ballpark, because we may be on the higher side of things, but we're still going to be reasonably priced for the value that we provide. And then we're going to set ourselves apart from everybody else with this different process.
And
That's
you
awesome.
you spent a little bit of time, like that 15 or 20 minute kind of remote conversation and video call. So you're not,
and it doesn't. We're saving. We're kind of getting enough information out to the client to keep ourselves in the ball game without actually having to do a site visit. With modern technology, that's like, hey, we should be doing this. Every job where the client has the ability to use their phone to do a video call with you.
Totally.
We should be doing that for everybody to get an initial lay of the land.
That's awesome.
I think that's more and more in our future. I think it makes a lot of sense rather than driving out, spending an hour at least round trip drive time plus time on site.
Absolutely. It's good for everybody. You avoid both the homeowner and your business wasting time if you discover it's not a fit for whatever reason. Like, it's can be good for everybody. John, before we started recording, you'd mentioned this idea that heat pumps are easy for most of the country, and that despite kind of conventional thinking, installing a heat pump versus a conventional system is actually, they're not more expensive a lot of the time. Can you just talk about those two aspects, like this idea of heat pumps being easy and that they're...
Yeah, so heat pumps are easy. That's like the clickbait headline. With some caveats. I guess the way we look at it, we're in climate zone 4, climate zone 4A, mixed humid climate. Our design temperature in the winter is 18. Our summer design temperature is 91. We get extremes up to about 100 degrees in the summer. Usually we have a few hours in the single digits every year. Our all-time low is -9. So that's real. I have never seen that, but in 20 years, but that's the all-time low. But we get a wide range of temperatures. But I'm going back to my standalone consulting days, 15 plus year track record of heat pump design and heat pump installations. We're doing really, really well in terms of our process. The process is doing it by the book. Manual J tells you how to do it, and Manual S and Manual D and so on. And the authors, when the authors of Manual J say, do not add additional safety factors because it's already a conservative process, they're correct. Their process might be overly conservative, especially on the heating side of things. We find the cooling to be pretty good most of the time, and heating tends still. And the Manual J heating is just it's a traditional U value area delta T calculation with air leakage, duct leakage, and ventilation thrown in. So it's not some fancy process, but it does tend to overestimate the heat loss. That's a whole probably separate conversation around why that is and what should be done about it. But it definitely is. It definitely seems to be true. But yeah, we're in climate zone 4. When you look at the different climate zones and where people live in the U.S., 2/3 of the people in the country live in climate zones 4, 3, 2, or 1. So we're kind of in the hardest part of climate zone 4 on the northern end of climate zone 4. And everything below us, from a heat pump, like heating output and cooling output standpoint, it's mostly the heating output that people have concerns about. Cooling output for heat pumps is the same as the same size air conditioner. So cooling sizing for heat pumps is the same as cooling sizing for straight air conditioners. So it's kind of the heating that people are concerned about. So 2/3 of the country, 200 plus million people, are in zones 4 and below. So just from a like heat pump technology, like heat pump heating output standpoint, basic heat pumps work in our climate zone. Low end 20-year-old R22 single stage heat pumps work fine where we are with a decent enclosure and decent duct system. I think you have to throw in some caveats there. So it gets even better when you have more advanced heat pumps, variable speed, a little bit better heating output, or even better kind of a cold climate model. And everywhere south or warmer than us, that just gets easier and easier from a heating standpoint. I mean, you still have to take all of the same care in the design and installation process, but from like, can this thing put out enough heat to do the job? It's easy in climate for 2/3 of the country. It's easy. And then you get to like climate zone 5, like where you all are, where like Nate Adams, or where he is in West Virginia and where he used to be in Ohio, where other folks like Silas Hepner in Iowa, he's climate zone 5. Those are a little bit different, and each one of those has its own challenges in terms of the climate, but they're still doable with good heat pumps, especially if you make some enclosure improvements at the same time. And then you just added in a whole another huge segment of the population. And then you start to look at climate zone 6 and 7 and climate zone 8, and it's a pretty small. Yeah, heat pumps are can they do the job with the right design and install? It's pretty straightforward to do where we are, we think. And we're converting houses all the time over to heat pumps. And we already have a third of our houses in Virginia, roughly a third of our houses are already on heat pumps, most of them on kind of crappy single stage heat pumps. So you start doing better design, better equipment, better ductwork, better enclosures. It just gets easier and easier and easier to make heat pumps work. So that's the heat pumps are easy part.
It's a great answer. You also just named our 3 next episodes. So that was great too.
Awesome.
It was a heck of an answer.
That's good. What was it about? The second part of the question was...
Yeah, just
expensive.
Quickly on the expensive piece, yeah.
So, I guess first, just looking when contractors have access to the wholesale equipment prices, when people say they're more expensive, they're not comparing apples to apples. Often, they're saying a heat pump is more expensive than a furnace. Yes, that's true. They're not the same appliance. They're not doing the same thing unless you're in a climate that only requires heating. And we're at 90+% market share for not quite that much. We have a ton of central cooling. Most houses have some kind of cooling systems in the US. And so the correct comparison is a furnace and air conditioner. So furnace, AC coil, AC outdoor, that cost to heat pump outdoor unit and an air handler. And when you look at the wholesale cost for those 3 components versus heat pump components, for comparable product lines, so you're not comparing a variable speed cold climate heat pump to a low-end single-stage AC and 80% efficient furnace. You're comparing them to appropriate product lines. The heat pump is a good bit less expensive. And we've done a couple of jobs where we did a dual fuel or hybrid system, and it wasn't our preference because we rarely do that. Almost all of our systems are straight heat pumps, but we've done a couple of dual fuel systems, and they're always significantly more expensive to do because the equipment's more expensive and we're dealing with the gas. Now, when you're doing a heat pump conversion or an electrification, there are some one-time additional costs involved that are going to add some costs. So you're disconnecting the gas, you're capping that, you're capping the flue, you're sealing it at the outside wall, you're probably running new electrical depending on what the electrical needs are. So there are some one-time costs there that are involved. But if you were looking at it from just a new construction standpoint, a straight heat pump is way less expensive than a gas furnace and AC. So that's the cost standpoint. In places of the country where heat pumps are common, heat pumps are not crazy expensive. The only place you don't hear people in South Carolina, in Georgia, complaining that they're getting quotes for $30,000 heat pump systems. It's people in Massachusetts and California and Washington State. It often coincides with places that have huge rebates right now.
I was going to say, I can hear Nate Adams yelling into his microphone about the rebate impact. Yeah, totally.
No, and those rebates do often come with a lot of extra hurdles on the installer side. And I get why installers are taking some of that rebate because they have to do a bunch of extra work. Where we are right now, we don't yet have the state level IRA rebate funding yet. Our state just recently applied for that stuff. So we'll see what that program looks like. If it does get funded and get off the ground, I don't know. That's still up in the air.
Yeah.
But yeah, where we are, we have a heat pump rebate from our local utility that is so small that we can't even do the paperwork for the same for the amount that the rebate is to the customer. It's like a $250 rebate.
Wow.
It's no, we're not.
Super interesting.
It's not. Yeah, it's not even worth spending more than 30 seconds talking about. Whereas you all are looking at in Massachusetts, you're looking at 10,000. Yes. Yeah. They're big. Plus a heat loan. Right.
All right. Those are great answers on heat pumps are easy and expensive. This is the answers on everything have been great. We're going to do a different final question for you because all my conversations I've learned something. You're a man with his finger on the pulse of things that are new and cutting edge in the HVAC and building science space. So I'd actually like to know, What's at that bleeding edge that you're hearing about, thinking about, hoping for, that's got you excited?
It's really like what we're really talking about when we're talking about like leading edge or bleeding edge. We're talking about equipment, really, because the home performance work, the ductwork installations or modifications, the enclosure stuff, like that's all old. Like there's nothing new there. It's just doing the work. It's figuring out what needs to be done, figuring out if what the homeowner wants to do aligns with what in an ideal world what would be done to the house. It's finding that alignment with how the homeowner values things, what they were looking for. And unfortunately, it's almost never like taking an existing home and turning it into a passive house. That's like literally a 1 in a million job. So we're really talking about equipment, and there's not that in the ductless world, in the regular air source ducted world. There's stuff is really slow to change. The only stuff that I'm like kind of jazzed about is air to water heat pumps coming, more major manufacturers offering them in the US again. LG, we're doing our first install with one of those right now with an LG air to water heat pump. There's other, Daikin is supposed to be coming back. Samsung is at CES and AHR like right now and in the coming weeks showing off their product that they've been selling elsewhere in the world for years and years. So that stuff is really cool. It's really cool. I don't know how much traction it'll get because it's still the equipment's really expensive. There's not a lot of know-how. Hydronics, it makes everything like how you use it is like infinitely flexible from a designer standpoint. And that's awesome and terrifying at the same time because there's no like split system ducted stuff. Like that's like you're in a lane. Like, how to do that, how to design it. Like it's pretty well defined. Whereas the air to water heat pumps, like, is it going to be radiant heating? Are you doing radiant cooling? Are you doing ducted cooling? Are you going to go all ducted? Are you doing multiple zones? Are you doing buffer tanks? Are you going to add on a little towel warmer over here? Are you going to add some snow melt in their driveway? You can just go so far with it. And then, of course, all of those machines can do domestic hot water as well, which is, for me, that's like the first coolest thing is to be able to have that single appliance, pros and cons to that, but have that high efficiency outdoor unit that can provide that hot water inside and not have to have the extra noise and extra space requirements of a packaged heat pump water heater, which they have their place, but their applications are a lot more limited than what you can do with a split system hot water solution. So I think that's one that I'm excited about, but it's still slow going in the US. The equipment is all like, it's really expensive and the capacities are all big because the manufacturers are only expecting rich people in big houses to be interested in it. That's kind of my sense. And so we don't have like small air to water. In the UK and elsewhere in Europe, you can get a 3 kilowatt output. So it's like a 10,000 BTU per hour nominal air to water heat pump. You can get like a 2.5 ton, 30,000 for the smaller, those lower load applications. We don't have the good solutions yet. So that's one. And the other, which I fully expect you all will have a podcast dedicated to this topic, is networked geothermal, which you all have some pilots going on in your area. I think I'm definitely a skeptic in terms of like the cost and the efficiency overall of the system. I would be surprised if that stuff worked out really well, but I'm from a energy transition politics standpoint, it makes a ton of sense to take a gas utility and try to convince them to turn themselves into a thermal utility instead of being a gas utility, and using that as a way to shut down potentially neighborhoods at a time, or give them the ability to shut down neighborhoods at a time. That's all up for debate. There's that's obviously a lot of controversy around that, but I'm definitely in the boat of moving towards electrification.
Awesome.
But providing good solutions when you do that. I mean, you don't want to, especially if you're doing something that becomes mandatory, it needs to be like mandatory and a better solution at the same time, like demonstrably better solution.
Well,
yeah. You also definitely do a network geothermal pump.
Noted.
That's a great idea.
And I think it's so fun that, it's very exciting. There's definitely some cool pilots happening in that space, but it's new, but it's actually old. Cause like, that's how a lot of big systems 100 years ago, There were
Yes.
shared networked heating systems where you had a single
Right.
plant that was serving
Right. Yep.
neighborhoods or hundreds of buildings. And so it's like bringing the old back.
Yeah, and there's in the current generation, like the pilots in the US are like 10 years behind what's already been done in Europe. There's a heat pump company in the UK that is dedicated to designing and manufacturing heat pump equipment specifically for that kind of application. Although it's a heating only application, which is so they're harder to do in our market where we need heating, cooling, and domestic hot water. But yeah, other places are way ahead, but it's definitely, I think it's a cool thing to think about and definitely try in the more denser parts of our country.
Awesome. John, this was fantastic. We're so glad we finally made it happen. Thank you for joining us on the Heat Pump Podcast.
You're welcome, guys. It's been great.
Yeah, thanks so much. It's been super fun. Thanks for listening to the Heat Pump Podcast. It is a production of Amply Energy. And just a reminder that the opinions voiced were those of our guests or us, depending on who was talking. If you like what you've heard and haven't subscribed, please subscribe in your favorite podcast platform. We'd love to hear from you, so feel free to reach out. You can reach us once again at hello@amply.energy, no.com, just .energy. Thanks a lot.